Hello everyone. We'll be just waiting for a couple of minutes before others will join. Then we'll start. So after every question, some time will be given. In case you have any doubts regarding that particular question, you have to type in your doubts in this chat box only. No microphone or video on the chat box. So we'll just wait for a couple of minutes before others can join. Then we can start. I hope it's clear now. Actually, weather is not quite good here. So yeah, I'll just try to put my mic closer. We'll start at 3 p.m. So just a couple of minutes. Also, just to be clear, I'll be only adding participants after the particular question is solved. So in between, I won't be able to add any participants. So I hope that's clear. So I guess we can start. In case anyone joins in, he or she may have to wait for a particular question. So let me just share my screen. So I hope I'm audible and my screen is visible. So before we start, we are bound to give this introduction every week. So let me just give a brief introduction about myself. My name is Musab Rafiq. I'm a PhD student at IIT Kanpur. I'm your teaching assistant for this course on digital circuits. This is a live problem session number 2 based on the concepts that you have seen in tutorials of week 2. The course instructor is Professor Santanu Chattopadhyay from IIT Kharagpur. So I think some people have joined in. First I will admit them, then we can start with the first problem. So let's just take a look at the first problem. So the first problem says as given the following binary number, give the following binary in 32-bit single precision IEEE 754 format. The decimal value closest to this floating point number is. So we are given this number 32-bit floating point number in IEEE 754 format. We have to convert this number into the closest value, closest possible value in its decimal. So what we will do is we will just take, we know that the first bit in IEEE 754 format in a 32-bit single precision refers to as sign, and from second to ninth bit, that's 8 binary total, represents the exponent, and finally the remaining bits, that is from 10th to 32nd bit, represent mantissa. So here we have this. Let me just point options. So here this sign bit, this first bit is 0, which means a positive number, and this bit from second to ninth bits represent our exponent as shown here. So we have to subtract this number. We have to subtract this, that is this 2 raised power 7 number, that is 127, from the exponent. exponent is this. If we convert this into binary, this decimal, like we did it last time I showed you in this session, this is, if I'm not wrong, this is 124, and we have to subtract 127 from this 124, and the answer we get is this. We have this answer 011, that is 3. This is negative. So our number in this form, let me just wait a moment. And we have, and mantissa, that the remaining bits from this to this is our mantissa, is in normal form, so we can write it in this form, 1 and m is like this. M is equal to 1 1 0 1 1 0 1, and rest all over 0, so they are not written here. So our number can be written in binary form like this: 1.11 multiplied by 2 to the power minus 3. This 3 comes from this, and our final answer is, after shifting our number to this right position by 3 value, so we get our answer like 0.0011101101. Now the question asks us to show the closest value to this number in the decimal form. So what we do is we convert this number in decimal. So how we do is, it is 1 by 2 to the power minus 1 multiplied by 0 plus 1 by 2 to the power minus 2 multiplied by 0 plus 1 by 2 to the power minus 3 multiplied by 1, plus so on, like this thing, and it will be finally equal to 1 by 8 plus 1 by 6 1 by 16 plus 1 by 32 plus 1 by 128 plus 1 by 256, and finally 1 by 1024. If you add them up, the total comes out to be 0.2314, and if we denote in this notation, it is 2.3 into 10 to the power minus 1. And from the options, the closest number to this value is, I think, option C, 2.27 into 10 to the power minus 1. So the answer to this question is 2.27 into 10 to the power minus 1. So if you have any doubts regarding this question, please type in the chat box. I'll be giving just a couple of minutes, and I'll be admitting some other students also. So those who joined late, I was just discussing this problem 1, and now I'm just waiting for some, if there are any doubts regarding this problem 1. So those who joined late, they can refer to these recording sessions from the site. So I can't help you with that. So in case of any doubts regarding problem 1, you can type it in the chat box. So I think there are not any doubts regarding this problem. So we can move to the problem 2. So problem 2 asks us to express this number 32, which is given in decimal, in the revised 14-bit floating point model. So what we have is, we have this 32 in decimal, which can be written as 2 to the power 5, and when we normalize it, we can write it like this: 0.1 into 2 to the power 6. So this is our exponent, this 6 part. So in a revised floating bit point number, to use our revise, we have to add this 16 to this 6, and we get this 22. So this 22 is in decimal. So this 22 in decimal, now we convert it into binary like this: 2 11 0 2 5 1 2 2 1 and 2 1 0. So this 22 in binary will be 1 0 1 1 0. This will be our exponent. And now our mantissa is like this: 1, simply 1. So our revised floating point, so our number in revised floating bit floating point is, first will be the sign, which is positive 0, then will be the exponent 1 0 1 1 0, and then mantissa, which is 1, followed by remaining zeros, which will be this 1 2 3 4 5 6 7 7. It will be 7 zeros: 2 3 4 5 6 and 7. So the in floating bit floating point, the number will be 0 1 0 1 1 0 and 1 0 0 0. So I think this is option A. Let me just cross check: 0 1 0 1 1 0 and 1 0 0 0. So option A will be our correct answer. In case of any doubts, please type in your queries in chat box. I'll just wait for a couple of minutes. So I think there are not any doubts or questions regarding this problem. We can proceed further to this problem number 3 that I prepared. So this is again a problem related to the previous problem, where we have given a decimal number and we have to again converted this in the 14-bit floating point number. So here a negative number is given, and that too with the fractional part. So we are given this number minus 26.62510, and we have to convert it into 14-bit floating point number. So what we do is we first convert this number into into binary. So how we'll do it? We'll do it like this. First we take up the left hand side of the decimal number, that is 26, and we convert it into this binary part: 2 13 0 2 6 and 1 2 3 and 0 and 2 1 and 1. So the number will be 1 1 0 1 0. That is this part. And for the right hand side of the decimal, we have to multiply it by 222 continuously, and 0.652 into 1 will be, let me just take the help of calculator, 0.652 multiplied by 2 will be 1.25. So the integer part is 1, I is equal to 1, I is 1. So then we take the fractional part, that is 0.25 multiplied by 2. So it is 0.5, integer part is 0. Then we take the 0.5 and multiply it by 2. So it is 1.0, and integer part is 1. So our number will be 101. That's what I have written here. My number in binary 11010, that is here, and 101 the decimal part, that is here. And now we normalize the number and write it in this form: 0.100101101 raised to power 2 to power 5. So this is our exponent, and to use the bias we will add 16 to it, and we have this number 21 here. So now we will convert this 21 number into binary, and we have 2, 10, remainder 1, 2, 5, remainder 0, 2, 2, remainder 1, and 2, 1, remainder 0. So 21 in binary will be 10101. That's what I have written as 10101. Number is negative, sign bit will be 1. This is our exponent, and this part will be our mantissa. So the final number will be sign bit 1, represented by no exponent 10101, and the mantissa part, that will be 1101001, sign exponent and this part. So if we just check with the options, this is option B, 1101011 So option B will be the correct answer. So if there are any doubts regarding this question, please type it in the chat box. I'll wait for a minute before you can type in your doubts. Last step, yeah, I'll repeat it. I'll just wait for some more queries, then I can answer them together. So couple of minutes. If there are any queries. So I'll just repeat the last 2 or 3 steps. So we normalize this part, and we have this 2 to the power 5. By 5 is we add to this 16, and we have this 21. In decimal, this 21 in decimal is 10101. So that is my exponent part. The number was negative, so the sign bit was 1, and the mantissa of this here, this point 0.11, this one, 1101001 is my mantissa. So the number together in 14-bit floating point model is 1, the sign, this from the exponent part, and this from here, 1101001, and this thing here, 1101001. So this will be total 14 bits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is, so are there any other queries? I hope I was clear with this last step. If there are not any further queries, we can move to the next question. That is question number 4. So let's just move this question number 4. So question number 4 asks us to add these two numbers using the 14-bit simple floating point model. So we have this 12 in decimal and 1.25 in decimal. So what we do is we first convert them into 14-bit, both numbers into 14-bit floating point model. So first we take up this number 12. We convert into binary. 12 in binary is 1100. So let me just show you. 12, 2, 6, 0, 2, 3, 0, 2, 1, 1, 1, 1, 0, 0. That's what I have written it here. And now we will normalize it. So this will be 0.1100 raised to the power 4. And now we take up this number 1.25 and convert it into binary. So 1.25 in binary is, let's just take the left hand side of this number. This is this part. 1 is simply 1 in binary, and 2.25 it can be found in binary as 0.25 multiplied by the base of the number system, that is 2. So we get 0.5. So integer part is 0. Then 0.5 multiplied by 2 gives us 1. So integer part is 1 and fractional part is 0. So my number in this will be 0, 1. So my number in total in decimal will be 1.01. That's what I have written here, and now I will normalize it. So it will be written as like 0.101 into 2 to the power 1. To make up in both in same form, I'll just right shift the number. So it will be like this. This number is equal to this, so they will be in the same form. And now I will add up these two numbers. So adding 1 and 2, I get, we have 0.110101. So if we add like this, 0, 0, 0, 1, 0, 1, and you add it to 1, 1, 0, 0, and you just add a couple of zeros to the right hand side. So the addition will be 1, 0, 1, 0, 1, 1. So that's what I have written here. And now we have the answer to this to the addition of these two numbers, and now we convert this number into floating point. So this 4 is here. We will add 16 to it, and we get 20. And 20 in decimal is 10100. This is 16 plus 4, 20 simply. And this is the Mantissa part. So, and the sign of the number is positive. So first bit will be 0, followed by this exponent part, that is 1, 0, 1, 0, 0, and followed by this, that is 1, 1, 0, 1, 0, 1. So this will be my number 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1. I think this is option, no, this is 0, 1, 0, 0, sorry, this is 0, 1, 0, 1, 1, 0, 1, and oh no, it's 1, 0, 1. So my answer will be 0, 1, 0, 1, 0, 0, and 1, 1, 0, 1, 0, 1. I think this is no option is not there. Let me just cross check it in my solutions that I have prepared earlier. This option is not here. Let me just cross check the addition part again. 1, 0, 0, 1, 0, 1. Let me just cross check my solutions. So here error was here in the addition part. The error was there. So I have this number 1, 1, this part 1, 1, 0, 0, and I have this another number 0, 0, 0, 1, 0, 1. So I'll first write this number 0, 0, 0, 1, 0, 1, and my number again will be 1, 1, 0, 0. No, I think it should be same. I don't know why it's coming out different. We'll come to the later. This question we'll come to later. I think I'm making some errors here. 0 should be 1. I don't know why error is coming up. I'll just come in the end. We'll just come again to this part. The procedure will be same. I think I'm making some error somewhere. So we'll just come to this question later in the session. Now I'll move to this question 5. So I won't be taking any doubts with this question as I have not completed it. I'll just do it later. Let me just admit some students first. So now coming on to another question, question number 5, that is. Oh, the answer is correct. Sorry, answer is correct. If you can see, the answer is, I'm just missing up with the number of bits. Answer was correct. So these are not 14 bits. If you can just count them, 0, 1, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you have to add two zeros. So it becomes a 14-bit number. So the answer will be 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 0. And that is option C. So the solution was all the way correct from start. I'll just repeat it again. So what I did is I first converted this number 12 into binary. So it was 1100, and this 1.25 into binary, so it will be 1.01. So I'm normalizing both numbers, so it will be 0.1100 into 2 to the power 4, and this number would be 0.000101 2 to the power 4. Now I'll add them, these two numbers, so it will come out to be 0.110101. So this is our mantissa, 1, 2, 3, 4, 5, 6. So I'll add two more zeros here. That was where the doubt was. Here, not here, not here. So this is my mantissa and this is my the exponent. So I'll add 16 to it, I'll get 20, and when I convert this 20 into binary, I get this 10100. So this is my exponent, this is my sign, and this is my mantissa, 1100101. And to for the 12, to complete up the rest of the bits, I'll add up 00. So the number will be 0100100. So this is your answer. Now I can take the queries regarding this question if there are any. Sorry for the hiccup. It was correct all the way, but I just messed up with the number of bits. Any doubts regarding this? So let me just proceed to this question number 5. So the question number 5 asks us to simplify the following expression. So we are doing this expression f equal to bc plus or. Sometimes I say it plus, but in Boolean expression this is or, and the multiplication is and. So this is or BC complement or BA. So we have to reduce it into the simplest form. So what we do is we write it here. We write the expression f equal to BC plus BC bar plus BA. Then we take out this B common, and in the brackets we have this C plus C complement. We know this A plus A or A complement is always equal to 1. So here we have C plus C complement that is always equal to 1, and B dot 1 is B. In the next step I have written as this. So I have this F equal to B plus BA. Now I'll take B common, and I'll get this 1 plus A. 1 plus A is always equal to 1. So basically it is 1 or any variable, 1 or x is always equal to 1. So my final expression will be F equal to B. That is option A. So it was a pretty straightforward question, but in case of any doubts, please type it in chat box. So Mohammed Sari, I think you want me to repeat the last step, first step of question number 4, if I'm not wrong, huh? Or this question, question number 5. Kindly type in chat box. If it's question number 4, I will show it again later. But if it's this question, please type it. Any doubts regarding this question number 5? Question 4 will be revisited again at the end. So I think there are not any doubts regarding this question number 5. So I can proceed with the question number 6. So I can move to the question number 6. So question number 6 asks us to minimize the following Boolean function. Minimize the following Boolean function, this function that is given here, using algebraic manipulations. So we will first write the expression f equal to abc complement d complement plus abc complement d plus ab complement c complement d plus abcd plus ab complement cd plus abcd complement plus ab complement c d complement. So I'm just again saying this plus and plus. Mind it, this is this OR operation. So now what we do is we take out the common terms. So we take out this common term a b c complement, and we have this b plus d bar in brackets. Then we write this a b complement c complement d, and then we take out this a c d common, and we have this b plus b uh, complement here, and then we take out this a c d complement common, and we have this b plus d complement. Like in previous question, I said it like we have this expression a plus a complement. It is always equal to 1. So this will reduce to f equal to abc complement plus ab complement c complement d plus acd plus acd complement. And now we will take out this ac common between these two expressions, and we'll have ABC complement plus AB complement C complement D plus AC. So again we have this D plus D complement, that will again be equal to 1. So our expression will be reduced to this ABC complement plus AB complement C complement D plus AC. Now what I do is I take this A, this is A, mind that this is A, not A complement. I'll just clear this thing in my final slides, but mind that this is A, not A complement. A common between these two expressions, this first term and third term. So A, when I take A common, so what I get here is BC complement plus C. So we know this A, we have this expression A plus A complement B is equal to A plus B. So I'm using that thing here. So BC complement plus C. Here A is C and B is B, so it will be B plus C. So it will be A times C plus B plus A B complement C complement D. So then I can write it as F equal to AC, adding these two and these two, plus AB plus AB complement C complement D. Now I take out A common between these two, and what I get is AC plus A plus B plus B complement C complement D. So one thing here is, now take this formula again, A plus A complement B is equal to A plus B, but here A is equal to B and B is equal to C complement D. So when I write this expression A B plus B complement C complement D, so this I am considering as A and this I am considering as B with respect to this expression. So B will come again B, and this will be B plus C complement D. So now my expression reduced to this AC plus A plus B plus C complement D from this thing, and I add them AC plus AB plus AC complement D. Now I take out A common between this first and third term. I get A C plus C complement D. So again using this expression, so it will be A C plus D. I get AB plus AC plus D, and now when I add them up, I get AB plus AC plus AD. So this will be my final expression, and the answer to this question is option A, AB plus AC plus AD. So if there are any doubts and questions regarding this, please type in chat box. So I'm not seeing any queries. I can just move back to this part. Now coming to question 7. Question 7 asks us to convert a plus b plus c into canonical form. In canonical forms, it means every literal should be present in the term. Like here we have three literals a, b, c. Every every literal should be present in the term in the canonical form. So what we do here is we have this expression a plus b and a plus c. It can be written as a plus b plus 0, a plus c plus 0. So 0, this thing can be written as c and c complement, because we know that a and a complement is always equal to 0. And this thing here, the missing term here is b, so we write it as b complement. So that's what I have written here, and now I will elaborate them. So we know this, we have this expression a plus bc is equal to a plus b and a plus c. So using that thing here, a being a plus b and b being c complement, this thing becomes a plus b plus c, a plus b plus c complement. And using the same logic here, it will be a plus c plus b, a plus c plus b complement. So a plus b plus c is common, so we know that and a and a is equal to a. So since this term is coming up twice, we'll just write it once. Coming from this fact, a and a equal to a, and writing other two terms. So this will be our canonical form: a plus b plus c plus a plus b plus c complement plus a plus b complement plus c. I think this is option B. So option B will be your correct answer. So in case of any queries or any doubts, type it in the chat box. I'll just wait for a minute regarding any doubts. If you have any doubts regarding this question. So there are not any doubts with this question. We can go back to question number 8. I think yes, 8. So the question 8 asks us to minimize the following Boolean function using sum of products. So we are given this Boolean expression. Just wait a moment. We are given this Boolean expression f equal to a, b, c, comma d equal to summation of this sum of products like this. And we are asked to minimize the following function. So what we write, we first write the expression f of a, b, c, d equal to this, whatever is given. And for your reference, I have given this table here, but you can in exams or anywhere you have to go, try to create this table yourselves. For reference part, I have kept it here. So my 3 will be this, then I have this 7, 11, 12, 13, 14 and 15. So I will write up these terms. Writing up these terms, so I get this a complement b complement cd plus a complement b cd plus a b complement cd plus a b c complement d complement plus a b c complement d plus a b c d complement plus a b c d. You can just cross check them. Now I'll take out this common a complement cd, a complement cd common in between these two terms, a complement cd common between these three terms, and ab common between these four terms. When I take up CD common between these three terms, I get A complement B complement, or A complement B, or AB complement, or AB whole and with C complement D complement, or C complement D, or CD complement, or CD. Now what I do here is I take up this A complement common between these two terms, and when I do that, I get CD CD A complement B complement plus B plus AB complement, and as I said previously, B plus B complement will be equal to 1, and also taking out C complement common between these two terms and C common between these two terms, I get C complement and with D or D complement, or C and with D or D complement. So this will also be equal to 1, this will also be equal to 1. So my expression will now be C D and with A complement, or with AB complement plus AB and with C complement plus C. So this thing is again like this, and it will be equal to 1. So it will be CD A complement plus B complement. Oh, this will be equal to 1. And also what I have done in this step, I have reduced this thing. So let me just show you this step. So this is A complement plus A B complement. If you remember previously, I showed you this expression: A B plus A complement B is equal to A plus B. Here A is A complement and B is B complement. So the reduction of this thing will be A complement plus B complement. That's what I have written here. So my final expression will be CD A complement plus B complement plus AB. I think this is option A. So question number 8 will have option 8A as the correct answer. So if you have any doubts regarding this question, please type it in the chat box. So B and D options are same. Let me just check. B and D options are same. No, B and D. Yeah, they are. No, I think they are different. I think maybe for the previous part you are saying. No, they are different. And just check it. B and D are different. And option A is our correct option. Question 7. Okay, let me just check question 7. Question 7. A plus B plus C is here. A plus B bar plus C is here. Yeah, they are same. Yeah, they are same. So both options will be correct. Thanks for pointing it out. They are same. So both them will be correct. Yes. We can use this commutative property. So both of them are same. So they are both correct. So any doubts regarding question 8? Question 8. AB plus CD. AB plus CD. AB plus CD. A complement plus B complement. Yes. Yes, Avinash. Any issues with question 8? You want me to repeat it? I can repeat it. I'm not getting your. I don't think so. Answer will be simplified to AB plus CD. You just try it out. Maybe just try it out. I have not done it. I don't think so. It will be simplified to that thing. You can use KMap. Just try it out once. So now moving forward to this question number 9. So question number 9 asks us to convert this product of sum to sum of products. So it's simply for this question, whenever we are asked to convert this thing to this thing or this thing to this thing, so the missing terms will be your answer simply. So whatever the missing terms here are, your those will be your answer in the sum of product term. So 0, 1, 2, 4, 5, 6, 8, 9, 10. Its complement will be 3, 7, 11, 12, 13, 14, 15. So these will simply be your answer, converting from POS to SOP. So option A will be your correct option. 0, 1, 2, 4, 5, 6, 7, 9, 10 are present in product of sum terms. So the remaining presents to convert it into sum of products, we just type in the missing terms. So I don't think there will be any doubt with this question, but still I'll just check it. By KMap, if it is coming, so then that will be your simplified answer for sure. Since it was not present in the option, so maybe that's why I have marked it like this. If using KMap it's coming AB plus CD, then that's your simplified expression. I'll just also check it once I'm done with the questions. You can just try it. Maybe next time we can use the KMap in the problem solving session. That will be another problem. Try solving using KMap. So now moving on to this last question, that is question number 10. So the question number 10 here, question number 10 here asks us, if x equal to 1 in the logic equation x or z and y complement or z complement or xy complement, and with x complement or z complement x plus y, if x equal to 1, then which of the following is true? So what we do is we'll first write the equation as it is, then we just plug this value x equal to 1 is in this equation. So when x equal to 1, we just put it in this expression. So here replacing x by 1, here, here, this is one complement, and here. So we have this expression, this whole, this one complement. We will just first, one complement is simply 0, and then we have this expression like this. And we know that 1 plus any x is equal to 1. So this entire thing will reduce to 1. And we have 0 plus z complement 1 plus y equal to 1, and we have writing it in the simplified form, z complement 1 plus y equal to 1, and again 1 plus y will be equal to 1. So we have z complement equal to 1, that implies z equal to 0. Let me just check if it is any option. Yes, option C. So option C will be our correct option. So any any doubts regarding this question number 10? Nitish, you are asking me to repeat question number 10 or 9? 10, yeah, I'll repeat. So I have this expression: if x equal to 1 in the logic equation this, then which of the following statement is true? So what I have done is I first wrote the expression. I wrote this expression here. Sim Then I plugged this x equal to 1 in this equation. So replacing x by 1, this I replaced x by 1 in this equation. And I know this 1 complement is 0, so I have just written like this. So you know that 1 or x is equal to 1 always. So I have this 1 or with this expression, regardless of the value of this equation, this will always be equal to 1. So it will be then we have this expression z complement z complement 1 plus y equal to 1, and when we have this z complement 1 plus y equal to 1, 1 plus y will always be equal to 1. Then we have this z complement equal to 1, which is simply z equal to 0. That is option C. I hope you got my point. I will repeat it again. So I have written this expression here, plugged my value x equal to 1 here. Then I have written this expression like this. And I say it here, this 1 plus x will always be equal to 1. So this term will vanish away because this is equal to 1. Then we have this term only 0 plus z complement 1 plus y, 0 plus z complement 1 plus I. So this is simply equal to z complement 1 plus y equal to 1. 1 plus y will always equal to 1. So that implies z complement equal to 1. So z complement is 1 when z equal to 0. So option C will be my correct answer. So, yeah, I'll repeat question number 4. I know that. And Dr. Bikram Aditya just wants me to repeat question number 1. So I'll be just repeating these two questions. Then we can conclude this session. I hope there are not any doubts with question number 10. Hi Nitish, if there are any more doubts, please type in with question number 10. First, I will repeat question number 4, then I can come to question number 1 again. So I don't see any chats. Okay, it's clear. So now we can move to this question number 4. So we are asked to find the sum of these two numbers using the floating point model between these two numbers. So what I did here is I first converted this 12 into binary. It is simply 1100 and then normalized it. So 0.1100 into 2 to the power 4. This is expression 1. Then I converted this 1.25 into binary. This is 1.01. I have shown you the steps previously. So when normalizing it, it is 0.101 into 2 to the power 1. But to make up into them same exponent form, I just right shift the number, left shift the number by 3 values. So it comes out to be 0.000101 raised to the power 4. So now they are in the same exponent system, and now I add them. So 110 1100. I added with I had added with this. Sorry, I just messed it up here only. 0 0 0 1 0 1 needs to be added with 1 1 0 0. I'll add two more zeros here. So it will be 1. At their addition will be 1 1 1 1 0 1 0 1. So this is our Mantissa part here, and it will be 2 to the power 4. Now I have to add 16 to this 4. It will be 20, and this 20 is 10100 in binary. So my final number will be first the sign, that is positive 0, then the exponent 10100, and then the mantissa, that is 110101. So these come out to be 12 bits. So I add two more zeros here, and I finally get the answer, that is option C. Now coming back to this question number 1, so we have to convert this 32 bit single precision number to this closest decimal value. So in 32-bit IEEE format, we have this first bit, that is the sign, then the next 8 bits that are the exponent, and the following then the rest of the bits are the mantissa. Here the sign bit is 0, so the number is positive, and the exponent is 0 1 1 0 0 0. If you convert it into decimal, it comes out to be 124. So 124, so we have to subtract 0 1 1 1 1 1, which is 127. From this 124, it comes out to be minus 3, that is 1 1 in decimal system. 3 is 1 1 binary system, sorry. And mantissa is normal, so we can write it as 1 point m, where m is a mantissa. So m here is mantissa 110101, that is this part. And a to power 2 to power minus 3 comes from this subtraction part. And since it is direct to power minus 3, we'll just right shift the number by 3 decimal places, so it comes out to be this in the binary form. And once you convert this binary number into decimal, it comes out to be 0.2314, and this number can be written as 2.314 into 10 to power minus 1. So out of the 4 options, the closest number to this number is option C. I hope I was clear. So that was all for today's session. This was a week 2 live problem solving session. Now we will meet again, this time on Sunday, where we will discuss problem set for week 3 tutorials. So we'll meet next time. So if there are no many if there are no further doubts, we can just leave the session. Thanks for joining me. So we'll meet again at 3 p.m. next Sunday. Thank you.